Now let's see this one. Again, the same kind of question, but here we have three tables. One table is broken into three tables. Now whenever you get any such thing, see how do we get four tables? Maybe first they might have decomposed into two tables, and then they might have taken one of them and decomposed into the other, right? So there are various ways you could come at these three tables. You can take any of the sequence possible in arriving at these three tables, and you can observe them, which means like this, examine them like this. One way is maybe they might have divided this big table into these two tables, right? Like, now see this, they might have taken the big table and then they might have decomposed it this way and then this one here, right? Or there is also one more sequence possible. What is the other sequence? They might have taken these two in together, which means B C D, and they might have taken this one, which means A B, and then they might have taken these two, right? And then they might have got like this. So initial table is decomposed like this, and then this one is decomposed like this. So there are two ways. You can either imagine this one or that one, right? Anyway, you should see, while every decomposition, not every possible, any one of the sequence, right? You should see that the common attribute is a function, this candidate key. Now first of all, examine this decomposition. What is the common attribute? C. Now C plus, if I find out C determines D is there, which means definitely it is the common attribute for one of the tables. So this particular decomposition is lossless, right? Now let's examine this decomposition, right? Which means ABC is decomposed into these two, right? And now what is the for this table, what is the common attribute? B determines C, right? So therefore common attribute is B, and B plus is giving C. So what can we say? This particular table is this having the this key as common attribute. Therefore it is lossless. So either you can take this sequence and examine it, or you can take this sequence and examine it, right? Which means you can take this one. Yes, B common attribute is B, and B is a no key for this, because B plus is containing A. You can check it. If you find B plus, it is going to contain C, D, A, and so B, isn't it? So it is going to contain A also. So the common attribute is primary key for this. You need not check that. If you got one sequence, it is enough, right? So anyway, here it is going to be lossless. Now what about the dependency preserving? So let's observe this. Is it preserving all the dependencies or not? Let's see what are all the dependencies that we can get on them. So one is A determines B and B determines A. These two are non-trivial dependencies which are possible on this. Let's see if this is true or not. A determines B, yes, it is true. What about B determines A? Is it true on this? I mean, can you derive this dependency from that? There is no direct dependency which is saying B determines A, but then if you find out B plus on that, right, B plus is going to give us, what is that? B and then C and then D, because of DA, right? All of them, and definitely B is determining A. So this is true. These two are true, and they are applied on this, right? And what about this one? What are all the dependencies possible? This non-trivial dependencies. One is with B determines C, and other is C determines B. Let's see if they can be derived from that or not. B determines C, yes, it is clearly derived, right? And what about C determines B? It is not there, but then if you check it, C plus is going to contain C because of CD, because of DA, and because of A, B, right? Therefore C plus is containing B. So this is also possible, right? And on CD, what are the functional dependencies we have? One is C determines D, and other is D determines C, right? And C determines D is clearly there, right? Therefore it is possible. And what about this one, D determines C? It is not there, but if you find out D plus, we get because of DA and because of AB and because of BC, right? So what can we say? D plus is containing C, therefore it is also there. Now these are all the functional dependencies which we got. So if I apply a union of all these functional dependencies, all of them together should cover that. Then only we can say that it is the decomposition is dependency preserving. Let's see if all of them are covered or not. Is A determines B covered? Yes, A determines B is there, and B determines C, yes it is there, and C determines D, yes it is there, and D determines A, it is not there, right? But then on these functional dependencies, let's find out if D has the capacity to determine A, right? Only on these functional dependencies by finding out D plus. If I find out D plus, I get D, because of D I get C, and because of C I get B, and because of B I get A, right? Therefore D has the capacity to determine A even in using only these functional dependencies, and so it is also covered. So the resulting functional dependencies after decomposition, whichever are holding, is able to preserve everything, isn't it? Therefore we can say that it is functional dependency preserving, right? So it is both dependency preserving and lossless decomposition, right? It holds both the properties, and it is true.